Hello everyone. Today we are going to see how to generate V curves, inverted V curves, and what are the significances of them in synchronous motor. V curve is a plot that is drawn against stator current versus field current in a synchronous motor for different load levels. This is the graph drawn for per phase armature current and field current. Initially it is started from no load. At no load condition, the field current is gradually increased. When there is an increase in field current, the armature current will start to fall down. It will be initially at a lagging condition. It will come to a minimum position, minimum point. That point, the power factor of the system will be, motor will be unity. Till it reaches unity power factor, it will be in the lagging condition at no load. If the field current is further increased, the armature current will slightly increase in leading power factor mode. So let us see the graph of a V curve. Look at this curve. It is charted from no load test. So initially, the first curve, the bottom curve is drawn for no load condition. So at this condition, look at the value of current before the increment of field current. So when I increase the field current, when there is increase in field current, the armature current was at lagging. So when I further increase the field current, the armature current falls down and it comes to a minimum value at this position. So at this point, the power factor is assumed to be unity. So when the load is increased, when the load is again increased, that is, the machine is set to be in a half loaded condition. Half loaded condition means, for example, if the rating of a machine is 10 amperes, half load is 5 amperes. This ampere rating is of armature current, not in the field current. Okay. So our example, we have taken 10 amperes machine as an example. So half load will be 5 amperes. Now the machine is running, assume the machine is running at 5 amperes of power factor, amperes of load. The comparison between half load and full load, you can see the curve here, the difference between these curves, as well as half to full load. So when this load is increased, the minimum current required to be operated at unity power factor is increased from no load to full load. Look at this point. So this is the difference. At no load condition, a very minimum amount of current is required for operating at unity power factor. But in half load condition, we require more current to be running at unity power factor. Similarly, for full load condition, we further require more current to be running at full load power factor, unity power factor. So after further, if I increase the field current, the machine will be running at leading power factor. Usually we will not prefer the machine to be running at leading power factor, but in some cases, in synchronous machines, the field current will be adjusted to be operated in leading power factor. This is because to compensate the power factor issues because of other loads connected with the same bus bar. The point at which the unity power factor occurs is at the point where the armature current is very minimum. Look at this curve, you can find out the point. And this is the point at which the armature current is very minimum, and that is the same point where the power factor lies unity. The curve connecting the lowest points of all the V curves for various power levels is called unity power factor locus, otherwise unity power factor compound curves. Usually we will prefer the machine to be running at 0.8 lagging to 0.9 lagging. In practical cases, achieving unity power factor is very difficult. Usually we don't get unity power factor. So let us see the significances of V curves. Usually the manufacturers of the motor will be giving all the V curves and inverter V curves for different load levels. So when the machine is running at half load condition, it may be running at lagging power factor. So if you want the machine to be running at nearly unity power factor, you can adjust the field current corresponding to this graph shown given by the manufacturer. Similarly, we know very well that the synchronous motor is running at it's called as synchronous condenser. That means they are used as power factor correcting devices. So when the bus bar is meeting with fluctuations in power factor or troubles due to power factor, we can use synchronous motors to compensate that issues with the power factor. So when we know very well the field current, by adjusting the field current, we can get three different excitation levels, which are over excitation, under excitation, and critical excitation. At over excitation condition, the machine will be running at leading power factor. Under excited condition, the machine will be running at lagging power factor, and critical excitation, the machine is said to be nearly unity power factor. So these curves are very useful in adjusting the field current to get the appropriate power factor. So these are the inverted V curves. The inverted V curves are obtained from the graph against power factor versus field current. So different load levels have been given. At no load condition, we have a different curve. Full load condition, we have different curve. And half load condition, we have different curves. Look at this curves. So it is very clear that from the figures, if the synchronous motor at full load is operating at unity power factor, then removal of shaft load causes motor to operate at a leading power factor. So this is an experimental setup to obtain these curves. So usually look at this point. So the field winding of the synchronous motor is connected with the rheostat. Rheostat is a variable resistor. Usually it should be kept at maximum position to get minimum field current. So when the field current is very minimum, the armature current will be very high. So when the field current is increased, that is by decreasing the rheostat, field rheostat, the armature current will fall. So the armature current can be cut from this ammeter. So at a particular point, this ammeter reading will be very minimum. Then if I increase this current, field current further, the armature current will rise again. So it will look like V in shape. So these two, if you plot the graph for this and this ammeter, you will get V curves. So these watt meters, 2 watt meters, are used to find out the power in every phases. This is a 2 watt meter method. So from this power values, we can find out the power factor. So usually we know that line power, the power fed to a motor is √3 of VL IL cos phi. So we have the VL value here and IL value here. So from these values, we can easily find out the power factors at different load levels. So finding out power factors will be easy if you do this experiment. So this is how experimentally we are obtaining V curves and inverted V curves. Thank you. Kindly post your comments to nagarajan.a@kce.ac.in.